Hello and welcome. My name is Sunshine, the Project Manager, Sunshine Educational Resources, also known as Sunshine Academy. We're starting a series of free online lessons in mathematics for senior secondary schools in Nigeria. These lessons are ideal for those preparing for JAM, SSC, GCE, NAPTEP, and even students in the senior secondary 1, 2, and 3. We are covering the entire syllabus for all these examination bodies. So today we're going to be starting mathematics with the laws of indices. The laws of indices. The laws of indices. Okay. Now, supposing we want to play with these numbers in this form, of course, you know that mathematics is about playing with numbers, just the way children love to play with toys. In maths, what we do is to play with numbers, which is our toys. Now, supposing we want to play with these numbers in this format. For example, you have, let's continue this way. We have 2 times 2 times 2 times 2 times 2. That's about 1, 2, 3, 4, 5, 6. No, 5, 2, making it 6. Now, let's write another array of 2. Again, 2 times 2 times 2 times 2, that's about 4 times 2, that's about 5. Let's write another array, the third one now. 2 times 2 times 2 times 2, that's about 4. Let's make another array. Let's say 2 times 2 times 2, that's 3 of them there. Okay, now these numbers can be expressed in the form of 2 raised to the power 1, 2, 3, 4, 5, and 6. We have 6 2's here. So this number can be expressed as 2 raised to the power 6. This one can be expressed as 2 raised to the power 1, 2, 3, 4, 5. 2 raised to the power 5. This one can be expressed as 2 raised to the power 4. And this last one can be expressed as 2 raised to the power 3. All right, let's move on. All right, we have expressed the long arrays of 2 in the form of 2 raised to the power 6, 2 raised to the power 5, 2 raised to the power 4, and 2 raised to the power 3. Now, let's try to understand some basic concept about these numbers. For example, let me bring down these 2 raised to the power 6. This 2 here is called the base. And this 6 here is called the index. The index. Okay. Similarly, let me bring down these 2 raised to the power 5. In the same manner, this 2 here is called the base. And this 5 here is called the index. From what we've understood above, this 6 here, this 5, this 4, and these 3 are called the indices. They are called the indices. We call them indices. So the 6, the 5, the 4, the 3 are called the indices. Now let's move on. Now, let me bring the numbers down here. 2 raised to the power 6, 2 raised to the power 5, 2 raised to the power 4, and 2 raised to the power 3. Now, supposing we want to perform these operations like this. Say 2 raised to the power 6 multiplied by 2 raised to the power 5. Or we even say 2 raised to the power 5 divided by 2 raised to the power 3. Now, for you to be able to perform these kind of operations, we have to follow certain rules or guidelines, or what is referred to as laws. And these laws are referred to as the laws of indices. These laws are referred to as the laws of indices. So let's go to study the laws of indices. Okay, now law number 1 a raised to power m multiplied by a raised to power n is equal to a m plus n. That is rule number 1. Notice what we've done to the indices when you multiply. During multiplication, or when performing a multiplication operation, you simply add up the indices. Okay, that is rule number 1. Now let's go to rule number 2. A raised to power m divided by a raised to power n is equal to a m minus n. Notice what we did to the indices. When you are dividing or when you are performing a division, you simply subtract the indices. Okay, now let's go to rule number 3. A raised to power m bracket open and close raised to the power n is equal to a m n. This is very simple. All you have to do is to multiply this index by the power to which the index is raised to. Okay, you multiply the index by the power to which the index and the base are raised to. Okay, now let's move to rule number 4. All right, rule number 4, the simplest of them all. Rule number 4 says that a raised to the power 0 is equal to 1. A raised to the power 0 is equal to 1. Now, it simply means here that anything raised to the power 0 is equal to 1. Anything raised to the power 0 is equal to 1. Now, sometimes, how do you come about these circumstances of a raised to the power 0? Take, for example, you have a raised to the power m divided by a raised to the power m. This is equal to, let's follow the laws of indices. According to the law of indices, it becomes a m minus m, and this becomes what? A raised to the power 0, and this is equal to 1. Okay, now let's move to rule number 5. Let's move to rule number 5. Now, rule number 5 says that a raised to the power minus n is equal to 1 over a raised to the power n. A raised to the power minus n is equal to 1 over a raised to the power n. All right, let's move on now. Now, let me show you some circumstances that would lead to this kind of expression. Now, supposing we have an expression like this: a raised to the power 0 divided by a raised to the power n. Now, this is the same as writing a raised to the power 0 minus n. I believe you know what I'm doing. A raised to the power 0 divided by a raised to the power n is the same thing as writing a raised to the power 0 minus n. Now, this is the same thing as writing a raised to the power 0 minus n is the same thing as minus n. Now, you can see it, and this becomes is equal to 1 over a raised to the power n. Now, let me put it this way for more clarity. Supposing we put this one like this, equal to, okay, a raised to the power 0 over a raised to the power n. I think you will understand it better this way. A raised to the power 0 divided by a raised to the power n is the same thing as what we've done here. It's the same thing as what we've done here. A raised to the power 0 divided by a raised to the power n is the same thing as what we have here. Now, this is the same thing as a raised to the power 0 is equal to 1 and an. I hope that is clear. So these are the circumstances that will lead you to a raised to the power minus n is equal to 1 over an. That is rule number 5. Now let's go to rule number 6. Rule number 6 says that a raised to the power 1 over n is equal to the root a of n. A raised to the power 1 over n is the root a of n. Okay, that is rule number 6. Now rule number 7. Rule number 7, okay, says that a raised to the power m over n is equal to root a of n raised to the power m. Our rules are getting more complicated. But don't worry, with time you will get to understand them. So a raised to the power m over n is root a of n all raised to the power m. Okay, so this is the last rule or the last law in the laws of indices. A raised to the power n over a raised to the power m over n is equal to root a of n all raised to the power m. Okay, now we're going to solve some simple problems involving laws of indices. Let's move on. So now we're going to take some examples. For example, let's have these examples. Let's take some examples now. So example 1, let's take example 1. 5 raised to the power 3 multiply by 5 raised to the power 4. Okay, 5 raised to the power 3 multiply by 5 raised to the power 4. In the laws of indices, we say that when you are multiplying, you simply add the indices. So this is the same as writing 5 raised to the power 3 plus 4, and which is the same as writing 5 raised to the power 7. Now example 2, 3 raised to the power 9 divided by 3 raised to the power 4. Now this is the same as writing, this is division, so 3 raised to the power 9 minus 4, which is equal to 3 raised to the power 5. 3 raised to the power 5. Okay, now example 3, 5 raised to the power 3 bracket open and close raised to the power 2. 5 raised to the power 3 bracket open and close raised to the power 2. Now this is the same thing as writing 5 raised to the power 3 times 2, which is equal to 5 raised to the power 3 times 2 is 6. Okay, now these are simple examples. As we proceed, we will get to a much tougher and tougher examples, but with this one you will be able to assimilate and be able to understand and digest the laws of indices. Now let's move on. Example 4 now, 2 raised to the power 3 divided by 2 raised to the power 3. This is the same as writing 2 raised to the power 3 minus 3, which is equal to 2 raised to the power 0, which is equal to what? 1. And this brings me to the end of this tutorial. In the next tutorial, we will continue with more sophisticated examples using laws of indices and even equations requiring laws of indices. Until then, make sure you practice. Practice, they say, makes perfect. Do not memorize these laws. One of the best ways to let these laws simmer in your heart is through constant practice. Do not forget to tell your friends, classmates, neighbors, junior ones, and your uncles and aunties to learn mathematics from Sunshine Academy. And if you have not subscribed to our channel, please do so that you can have instant access to our educational videos each time we release them. We also have lessons and tutorials in subjects like chemistry, physics, biology, geography, and so on. So thank you very much for watching, and God bless you.